Here are the formulas we'll be using. For instance, if I want to find the sine of 105, I could take the sine of 45 and 60 and plug into the formula as you see it. Since I'm using the plus sign, it matches with this plus sign on top, color-coded black and black. More specifically, all I've done is plug in. When talking about u would represent the 60, so sine of u, cosine of u. And v represented by 45, so cosine of v. V being 45. So at this 45, we also have 45 here. With that in mind, and knowing my two triangles, meaning if this is 60, I would have radical 3. Here's my 1 and here's my 2. And with the 45, 45, 90, 1, 1 in radical 2. So the sine of 60 would be radical 3 over 2. And the cosine of 45, adjacent over hypotenuse, would be 1 over radical 2. Add that to cosine of 60. The cosine of 60 is going to be 1 for the adjacent, 2 for the hypotenuse. And the sine of 45 would be 1 over radical 2. Multiply together, radical 3 over 2 radical 2. Multiply together, 1 over 2 radical 2. Combine like terms to get 1 plus radical 3 all over 2 radical 2 as my common denominator. For the second problem, if I do the tangent of 15 degrees, I'm following the tangent formula. But here, I'm going to use 60 for u, and I'm going to subtract v, where v is going to be 45 degrees. I'm going to plug into the formula using u as 60 and 45 as v. And it looks like this. Notice that since I decided to subtract, I'm reading the pink, the lower portion. So tangent minus tangent, and then on the denominator 1 plus the tangents. Evaluate using your 30, 60, 90 triangles and your 45, 45, 90 triangles, showing the tangent of 60 to be radical 3 over 1, the tangent of 45 to be 1 over 1. Finishing the formula, there's the 1 in the denominator, plus, again, the tangent of 60, radical 3 over 1, and the tangent of 45 to be 1 over 1. Simplifying further, we have this for an answer. I encourage you to push pause and see if you can figure this one out yourself using the cosine formulas. Pushing play, I would use the cosine of 45 plus 30. U would be 45, V would be 30. That would give me the cosine of 45 times the cosine of 30. And I would be using the top, which then switches to a negative in the formula box, sine of u, which is 45, and sine of v, which is 30. One more time, because I chose u plus v, I'm reading the top part, which is black. Following the formula, the top part, which is black, shows a negative sign. Evaluate with your 30, 60, 90, and 45, 45, 90 triangles. The cosine of 45 would be 1 over radical 2. And the cosine of 30 would be radical 3 over 2. And the sine of 45 would be 1 over radical 2. Here it is. Sine of 30 would be 1 over 2. Multiply numerator, numerator, common denominator, and simplify. Here would be your answer. However, your textbook may or may not want the rationalized answer where you get rid of the square root in the denominator. Meaning, I'm going to multiply everything top and bottom by radical 2. And when I distribute, I'm going to get radical 6 minus 1 radical 2 for the top, and then 2 times radical 2 and radical 2 make the square root of 4, for an answer of radical 6 minus radical 2, no, those cannot be combined, divided by 2 times 2, which is 4 for your total answer. Should you need them, here are some helpful identities, all of which you have seen before. Those identities help you solve problems like this, where we change, we manipulate tangent to become sine over cosine, and secant to become 1 over cosine, so that when we distribute, we get cosine times sine all over cosine, and cosine over cosine, which then simplify to give you the answer of sine minus 1. And here's a big deal. X squared plus y squared equals 1, the basic formula for a circle, the unit circle. X and y, where x represents cosine and y represents sine, now substitute in to give us cosine squared plus sine squared equals 1. It's kind of a big deal for where we go with this. So if I take the sine squared plus the cosine squared equals 1 and divide everything by cosine squared, I wind up with a new set of identities. Sine over cosine is tangent. Cosine over cosine is 1. 1 over cosine is secant. Since they're squared, they stay squared. Likewise, if we take the sine squared plus the cosine squared equals 1, definition of a circle, and now divide everything by sine squared, my new answers become 1 plus cotangent squared, and then recall 1 over sine squared is cosecant squared. Here is your summary. You'll use those identities in problems like this. If I simplify this, I can begin by factoring out cosine squared. But wait, I recognize this. This is the same thing as 1. So my simplified answer is just cosine squared. Or try this one. the sine of t. Cotangent I can manipulate or change the way it looks to change it to cosine over sine. When I multiply the cosines together, I get cosine squared. Getting the common denominator, I would multiply by sine over sine to get sine squared of t over sine. Add to the original element. Now I have a common denominator, and sine squared plus cosine squared. But wait, again, this is 1. But wait, this is cosecant. Answer done. And here are 2 more for you to try. Pause, see what you get. First problem, manipulate cotangent to change it to cosine over sine, and then cosecant becomes 1 over sine. When you are dividing by a fraction, that's the same as multiplying by the reciprocal. Little cross cancel here, and I wind up with an answer of cosine negative theta. For the second problem, think FOIL. First, outside, inside, last. Becomes sine times secant plus sine times cosecant plus cosine times secant plus cosine times cosecant. Now manipulate. Secant is the same thing as 1 over cosine. Cosecant is the same thing as 1 over sine. Secant still the same thing as 1 over cosine. Cosecant still the same thing as 1 over sine. Simplify. Sine divided by sine is 1. Cosine divided by cosine is 1. But wait, there's more. Sine over cosine is tangent. 1 plus 1 is 2. And cosine over sine is cotangent. Did you get it right? If so, you are good to go. Section 7.1, due on Tuesday. Your homework.